Okay, we're going to talk about 3 carbon units. So, one of the interesting things about metabolism is that we have a number of 3 carbon units that in the liver are very interchangeable. So, that's where we come up with the interchange in metabolism here. These 3 carbon units are used at this level of understanding a more or less. So we have 3 carbon units, 3 carbon backbone. When we get to the pictures, you'll see that every one of them has that 1, 2, 3 carbons that are the heart or the backbone of their structure. So all 5 of these 3 carbon units can be used to make glucose. Gluconeogenesis, we take 3 carbon units, um, take 2 of them, we stick them together, we make a 6 carbon glucose. The liver, as we'll see here, is a very metabolically active. It's involved in a number of the pathways. The liver handles a lot of things, changes a lot of things, converts a lot of things. The liver can pretty much turn each of these into any one of the other 4. And we'll show you the slight differences that are there. And you can probably see that this happens pretty easy. So the 5 what we're talking about here are propionic acid, lactic acid, pyruvic acid, glycerol, and alanine. Most of you know about propionic acid. It's a VFA, so 1, 2, 3 carbons. It's either got its hydrogen, so it's called propionic acid, or it's lost its hydrogen ion, and then it's propionate. Lactic acid, the difference between the two is we add the alcohol group here on the middle carbon. Again, 1, 2, 3 carbons with or without the hydrogen. So carbon backbone, carbon backbone. So just a slight difference there. We go down to pyruvic acid, and you're going to have a ketone group here on the second carbon. So with all 3 of these acids, the only real difference is you've got the same outside groups, same outside group. The difference is that middle carbon. We have the alcohol group for lactic acid, and then we've got the ketone group for pyruvate, with and without the hydrogen there. Glycerol, this is what we attach to 3 fatty acids to make a triglyceride. They do the dehydration reaction right here, 1, 2, 3. We add the fatty acids on that side. 3 carbons, no acid group in this one. Alanine is an amino acid. We have the amino group here attached to the second carbon. Normally we think of it as H nitrogen, carbon, carbon. Alanine's got that R group of a methyl group. So HCC is how we think of the amino acid, but we're thinking about the 3 carbon units here going through. So any of these starred compounds, the liver can make it, convert one back and forth to the other. All 3 can be used to make glucose. So we take those, we run glycolysis basically backwards. It's called gluconeogenesis. We take 3 carbon units, 2 of them, we bring them together, 3 plus 3 equals 6, 6 carbon glucose.